What up, guys? How's it going? It's been a while since I made some videos. The last video I made was April 2023, and even before that, right, we're talking September 2022. So I'm not gonna lie, I've been lagging, and there's a lot of students. I've seen all the comments, and I feel bad I wasn't able to finish this course, but I guess future students, you guys are lucky, because I think the semester is when I really put all that aside and just get to it. Again, just real quick, I do these videos for my sister that's currently an engineering major. I won't say where, but she's out there following my footsteps. So I do these problems because for me, very easy. This class came super easy for some reason, and it really isn't that hard, right? I mean, maybe it's your professor, who knows, but in these videos, I'll tell you guys exactly what methods I used to not get stuck. I mean, shit, a lot has happened, man. 2 years, the Celtics won their championship. Hell yeah, that's what I'm talking about. I now work for B-21, so that's pretty cool. That new bomber that just came out that got revealed in December 2022. Man, we're out here. Let's go ahead and start this problem. We got to determine the max deflection and the reactions and knowing the flexural rigidity's constant. So, something that they don't tell you in school that I wish they did was a lot of this stuff really is applicable everywhere. Okay, I mean, you guys just see A, B, P, L in this problem, but this is a guy jumping on a surfboard, on a diving board, right? This is a aircraft wing assembled to the center body. Legit, this problem poses a lot of real life scenarios that me and you guys, for sure you guys, right? You guys were in college, so things you never would have thought that were applicable in real life, or maybe you did, right? But I feel like that's what schools miss out on. All of this stuff really is useful. It's just different. It's just difference in magnitudes, right? P in this case could be a 20,000 pound wing, or it could be a 200-pound person jumping on a stick, right? Like I said, it's cool stuff once you actually start putting the pieces together as to why you're doing these problems to begin with. But you know what? Going back to FEA, in this case, these problems are straightforward. You start with boundary conditions, and then you start assembling your global equation. And I'll say it in the video later, but in these problems, for the remainder of the class, for the whole class, right? And I've said it in previous videos too, you either know one or the other, but you never know both, and you never not know one, if that makes sense. So at this case, if we know deflection at one location, that means we don't know the force. And if we do know the force, that means we don't know how much it's gonna deflect. So in this case, you'll see what I mean. Let's go ahead and get started. All right, so for these problems, you usually start off with the boundary conditions, right? So we'll go ahead and start doing that. In this case, we have two nodes, right? Give me 1 second, let me just write it down. Step one, boundary conditions. We have node 1 right here, which is node A, and then node B. Since it's continuous, we treat it as one whole long beam, right? That's all it is. So this, if you apply a force here, it's gonna deflect downwards, right? So max deflection is gonna occur at this location. So let's go ahead and put I'm gonna call them nodes 1 and 2. Okay, so just nodes 1 and 2 are going to deflect and rotate at a certain value, right? So let's go ahead and check it out. Node 2, for sure, right here, node B, that's fixed. So that's not going anywhere. That's going to be 0 in the y direction, and then it's not going to rotate. So that's also 0. V1, that is going to rotate some value, and that is going to display some value, and that's what we're looking for. And remember, for FEA problems, when you know one, you don't know the other. So in this case, we know V2 is 0 and phi2 is 0. So we know that there's a force. We don't know there's a force, but we know there is a force, right? We don't know what that value is, but there is something going on. There's a force reaction. If you apply this force going down, equal and opposite, right? Something's going up, and then it's also creating a bending moment. So like I said, you either know these numbers or the force and moments, but you never know both, and you never know none. So that's the trick to these problems, just FYI. So in this case right here, look, check it out. We don't know V1 or phi1, but we know there's a force here and there's no moment, right? So P is equal to, F1's equal to P, negative P, because it's going down, and then the moment is 0. So check it out. Now we could just go ahead and do step 2, go to our global equation, right? And this is just the force is equal to kx, but for your entire system. So you're going to start off with F1y and M1, F2y, M2. Okay, let's check this out. And then that's going to equal your kx, right? In this case, our k is all of this right here. So we already know all that. I'm just going to go ahead and plug. They say the flexural rigidity is constant. So EI, and then there's no value for L, but if there were, you know, I just make this into a number right here. No big deal. And then you have the stiffness matrix, right, for 2 nodes. So yeah, between 1 and 2. So in this case, it's a 4x4, no big deal. You'll see later on these things get complicated. Some go 6x6, and some can go even higher, depending on how many nodes you have, right? But essentially, the process is the same. It's no big deal, right? So let's go ahead and put this stiffness matrix into here, right? So we're gonna have, before I do that, let me go ahead and label it, right? It's V1, Phi1, V2, Phi2. And like I said, if you add more, you just keep going. V3, Phi3, depending on how many nodes you have. In this case, we only have 2, so we're good, right? Let's go ahead and finish off this matrix. 12, 6L, right? I'm just copying this. Minus 12, 6L. And if I'm in the way, I'm sorry, I already can't see my phone, but you'll check it out right now. Minus 6L, 2L squared. 12 minus 6L, 4L squared. I just copied it. And it's symmetrical, right? So the rows become columns. So 12, 6L, minus 12, 6L, minus 6L, 2L squared, and then minus 6L. Okay, and then you just multiply by your displacements, right? In this case, it's V1, Phi1, V2, Phi2, right? So V1, we have no idea what it is. So we're going to go ahead and put V1, Phi1, V2. Let me just go ahead and do it, Phi2, okay? All right, so now you start plugging in this. Remember, you either know this one or this one, but you never know both, and you never know none. I hope I said that right. So in this case, look, we don't know V1 or Phi1, so that means we must know F1y, and we must know M1, okay? And like I said, we do look, F1y, it's negative P, and there's no moment, so that's 0. And then in this case, we know these two, so that's going to 0, right? Because it's fixed, not going anywhere. So that's 0, 0, and then we don't know these, okay? So that's what I'm trying to say. So after that, it really is just algebra, you know? So look, in this case, since V2 and Phi2 are 0, what I like to do is cross out V2. There you go. Cross out V2, Phi2, and then this is also V1, Phi1, V2, Phi2. Okay, so these go away. Boom, boom. So now you're left with these 4, and that makes things way easier, right? Because now you could just go ahead and start doing your systems of equations. Step 3, right? Systems of equations. I think that's what you call it. It's been a while. I graduated like, what, 3 years ago, so. All right, so let's go ahead and do it. You put negative P, right? Equals, and don't forget the step right here, EI over L cubed, okay? Then it's gonna be 12 times V1. So let's go ahead and put parentheses, 12 V1 plus 6L Phi1, okay? 6L Phi1, boom. That's equation number 1. Number 2, it's 0 equals, and I mean, I would have put EI over L cubed, but then you divide it by 0, so it goes away anyways. So I'm just gonna go ahead and put 6L V1, right? 6L V1, 4L squared Phi1 plus 4L squared Phi1. And let's go ahead and simplify some stuff, right? This equation will become 12 V1 plus 6L Phi1 is equal to negative P L cubed over EI. And I already verified all this, so no offense, but I'm right, you're wrong if you didn't get the right answer. And then I'll go ahead and do the next one. 6V1 plus 4L V1 equals 0. Okay, I just organized the equations, no big deal. In this case, I just divided by L, and this one, I just moved all this to that side. That's all that happened. Okay. Now if we go to the next step, step 4, and we're just kind of using these two equations to cancel out one of these two. I mean, in this case, you could cancel out V1 and V1, right? Multiply this by -2, then add the two equations together. So let me go ahead and do that. 12V1 plus 6L V1 equals -PL cubed over EI. Then the bottom equation, it becomes -12, right? Because I'm multiplying everything by -2. The whole point of this is I could cancel these two out, and then I could solve for V1. So when I do that, 12V1 minus 8L V1 equals 0. Add them together, remember? So you'll get, let's go ahead and do that using both equations. You are going to get -2L V1 equals -PL cubed over EI. And then solve for V1, and you will get PL squared over 2EI. And boom, we got V1. And I mean, don't worry about what the question asks. At the end of the day, you're looking for all your V's and P's, and then all your forces and moments, okay? Keep it that simple. Don't get confused on what they're looking for. It's better to just solve for everything. At the end of the day, you're gonna have to, right? It's like if they had said solve for F2 and M2, well, I can't do that without finding this stuff first. So it's like just solve for everything, no big deal. The process is all the same, it's pretty straightforward. Knowing V1, now step 5, find V1, right? So now plug in V1 to any of these equations, it should give you the same answer. So once you do that, you will get -PL cubed over 3EI. And then that's your V1. And then, now that you have these two, well, now you have all four, right? You have V1, which is this. You have V1, which is this. V2, V2. Now you can solve for your F2 and M2 in this case. So now I'm gonna do the same thing. Step 2, find F2Y. There's a Y, right? Because we don't care about axial. These problems to this chapter only cares about transversely loaded members. You only care about the bending moment and the rotation, transverse displacements, right? So we don't care about any x direction. So in this case, find F2Y, right? F2Y, and then we're also gonna find M2. So F2Y equals, let me see, there you go, you can see my paper. F2Y is going to equal to EI over L cubed, right? All I did was F2Y is equal to EI over L cubed. In this case, it's the third equation, right? So we're using this, -12V1 minus 6LV1. Okay? And you don't have to do the rest, right? Because it's just 0. 12 times 0 is -6L times 0. So those go away anyways. Plug in your V1, V1, and you will get F2Y is equal to P. And then if you do the same thing for M2, you will get EI over L cubed, 6LV1, right? 6LV1 for M2. So M2 is equal to EI over L cubed, 6LV1, 2L squared V1. Boom, 2L squared V1. And then for M2, you will get minus PL. Now, the cool thing about this class is these things make sense logically, right? So quick static analysis, right? Some of the forces in the y direction will tell you if you have a P going down, you need to have a P going up in this case. So yeah, confirmed. And then if you have a moment, well, moment is just P times L. So that alone tells you this. Now the negative, in this case, what do you call it? Counterclockwise. And that's the trick about FVA. Well, actually, no. Yeah. So in this case, if you have a PL going this way, that means this way is pushing that way. Does that make sense? At location B. So it's a clockwise motion. So you have a negative PL. And this is just same thing, just nicer, right? This is when I have time. This is when I would just want to rush the videos. But it was a simple problem, no big deal. They get a little more complicated, but shouldn't be an issue. You guys will see. But yeah, that's it for this video. Let me know if you need help. Like I said, this one you shouldn't, but I guess we'll see.